Hi everyone, here are your notes on Pythagorean theorem, which you did in class the other day. Go through these and check over your notes and we will go over any questions you have next class. Okay, so first we're going to look at the triangle inequality theorem, which says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we look at these examples, we have apparent side lengths of triangles, and if we check this theorem with those, we can determine if those three sides can make a triangle or not. So if you look at the first one, 3 plus 6 is definitely greater than 2. Okay, 6 plus 2 is greater than 3, but 3 plus 2 is not greater than 6. So those can't make a triangle. Okay, if we look at example B, 7 plus 5 is greater than 4, 5 plus 4 is greater than 7, and 7 plus 4 is greater than 5. So yes, you can make a triangle there, and then it will also work for the last one. 4 plus 7 is greater than 8, 7 plus 8 is greater than 4, and 8 plus 4 is greater than 7. All right, so now let's look at Pythagorean triples. So Pythagorean triples are sets of three whole numbers. Now they have to be whole numbers, they can't be decimals, that satisfy the equation a squared plus b squared equals c squared. One common Pythagorean triple that you guys will see a lot is 3, 4, 5. This also means that the sides of a right triangle are in the ratio 3 to 4 to 5. Okay, so 3, 4, and 5 is a very common one you will see. Another common one is 5, 12, 13. So if you plug those into Pythagorean theorem, you would satisfy that equation. Now what's special about these Pythagorean triples is multiples of them also work. So if I were to double 3, 4, and 5 to get 6, 8, 10, that would also satisfy Pythagorean theorem. If I tripled it to 9, 12, 15, that would work. Same for 5, 12, and 13. If you doubled it, tripled it, quadrupled it, whatever, you would satisfy the equation. So formally now, you're going to get Pythagorean theorem, which says in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So what you want to remember in Pythagorean theorem, C is always your hypotenuse. Okay, so C is always going to be your hypotenuse, and then it doesn't matter which legs you call A and B. You can pick whatever you want. The only important one is that your hypotenuse is labeled as C. Okay, and remember it's always across from the right angle. Alright, so let's try an example. We're finding x. So if you look at this triangle, the missing side is the hypotenuse. So I'm going to label that C, and then the other sides I can call A and B. So if I write out Pythagorean theorem, a squared plus b squared equals c squared, okay, I get 15 squared plus 6 squared equals x squared. Okay, it's 225 plus 36 equals x squared. Get 261 equals x squared, and when we take the square root of both sides, we are going to get a decimal, okay, and we get about 16.16 for x, okay, which only means that those three numbers do not make a Pythagorean triple, okay, but you can get a decimal, that's totally okay. Now the converse to the Pythagorean theorem is also true. So if the sum of the squares of the shortest sides of a triangle equal the square of the longest side, then you can discover that the triangle is a right triangle. So if I were to give you this triangle ABC, and I said, you know, is it a right triangle? Okay, you would use Pythagorean theorem, pick the longest side to be your C, and then the other two, A and B. Okay, and then using Pythagorean theorem, plug in your numbers. Okay, so we'd get 15 squared plus 36 squared equals 39 squared. Okay, square those out. 225 plus 1,296 equals 1,521. And when you simplify on both sides, you get 1521 equals 1521. So if both sides of the equation equal each other, yes, this is a right triangle. Okay, now say what you get on one side of the equation does not equal what you get on the other side. That means your triangle is either acute or obtuse. So remember, acute meaning you have all three angles smaller than 90 degrees. Obtuse, one of the angles is larger than 90. Okay, so we have these three triangle inequalities to determine what kind of triangle we get. You always let the longest side be C. So if C squared equals A squared plus B squared, then we get a right triangle, like you just saw in the example we did before. If C squared is, remember your inequality symbols, if it's greater than A squared plus B squared, then your triangle is obtuse. And if C squared is less than A squared plus B squared, then your triangle is acute. Okay, so let's try an example. What kind of triangle is formed with sides 7 inches, 8 inches, and 12 inches? Okay, so right away, I can see 12 is my longest side. That's going to be my C, and then I'm going to use A and B for the other two. All right, so I'm going to do C squared equals A squared plus B squared, and we're going to see if that equal sign is true. Okay, so I get 12 squared equals 7 squared plus 8 squared. It's 144 equals 49 plus 64. Okay, and when I simplify that, I get 144 equals 113, which is not true. 144 is greater than 113, and since 144 was my C squared, that means my triangle is an obtuse triangle. All right, so let's look at some practice problems. Number 1, the sides of a triangle have lengths x, 2x minus 10, and x plus 10. If the length of the longest side is x plus 10, what value of x makes the triangle a right triangle? Okay, so this problem can look scary. All you're asking you to do is use Pythagorean theorem, figure out what values of x will make Pythagorean theorem work. Okay, so if x plus 10 is my longest side, that has to be C, and then it doesn't matter which other two are A and B. I'm going to calibrate the board because my pen is off. Give me 1 second, guys. Okay, so if I use A squared plus B squared equals C squared, okay, and I'm going to plug in my values. Now you have to be very careful when you do your multiplication that you are using FOIL correctly. So I get x squared plus 2x minus 10, that entire quantity squared, equals x plus 10, the entire quantity squared. Okay, so x squared, that's going to stay the way it is. Now, when I start foiling, okay, you guys used to do first, outer, inner, last. Okay, there is a shortcut you can do for foiling, which we will do lots of practice with this unit. Okay, if I look at the first term, 2x, square of the first term plus double the product plus the square of the last term. So the square of the first term is 4x squared. The product of 2x and negative 10 is negative 20x. Double that and you get negative 40x. And then the square of negative 10 is plus 100. Okay, and if you were to FOIL and do first, outer, inner, last, you would get the same thing. Okay, now if I do my shortcut for foiling on the right side, square of the first term is x squared. My product, x times 10 is 10x. Double that, so you get plus 20x. And then the square of the last term is 100. Okay, so now what I want to do is start simplifying. Okay, I get 5x squared minus 40x plus 100 on the right. And I want to start subtracting everything to one side. Okay, so if I subtract an x squared, I'm left with a 4x squared. And if I subtract 20x, I get negative 60x. And then if I subtract 100, they cancel out. So I'm left with 4x squared minus 60x equals 0. Now what I am allowed to do is divide by the common factor here. Okay, 60 is divisible by 4 and both terms have an x. So if I divide everything by a 4x, I can simplify. Okay, I will be left with x minus 15 equals 0. Okay, and x is 15. So if x were 15, that would make those expressions lengths of a right triangle. And if I check my work, my sides will be 15. 2 times 15 is 30 minus 10, so I'll get 20. And 15 plus 10 is 25. So those would be my sides of my triangle. And if you put this into a ratio, 15, 20, and 25 are all divisible by 5. They would reduce to a 3 to 4 to 5 ratio. So they are a Pythagorean triple. Okay, next, give the values of x, y, and z that will justify that the ladder to the slide is perpendicular to the ground. Okay, perpendicular means to form right angles. So if this were to form a right angle, that means we have a right triangle here. Okay, so we need to check all of the choices that satisfy Pythagorean theorem. Okay, now when you get a problem like this, you want to look for Pythagorean triples. Those are the quick things to find. So remember, if you look quickly at number 2, 5k, 12k, 13k. If you look at just 5, 12, and 13, that's one of those Pythagorean triples we talked about. Just having the k in there makes them a multiple of that. So number 2 works because 5, 12, and 13 are a Pythagorean triple. Okay, if I look at number 1, if I did 15, 36, and 39, okay, all of those, if you do Pythagorean theorem, simplify, okay, and satisfy the equation. So number 1 would be an appropriate choice. If we did Pythagorean theorem with number 3, you would get 144 plus 324 equals 441. They don't equal each other, so we know number 3 cannot work. If you look at number 4, s squared plus 9s squared, if you square everything out, does not equal 16s squared. So they do not satisfy Pythagorean theorem. And then number 5, p squared plus square 2p, you get 4p squared, equals the square root of 5p squared squared. Now, you guys know what happens when you square a square root. They cancel each other out. So we are still left with just what's under the radical, 5p squared. 5p squared equals 5p squared. So that means number 5 works as well. Okay, and lastly, number 3, what kind of triangle has sides 12, 14, and 7? Okay, so C is 14, that's my longest side. So if I do 14 squared equals 7 squared plus 12 squared, I get 196 equals 49 plus 144. Okay, and I get 196 does not equal 193. So 196 is greater than 193, which means my triangle is obtuse. Okay, and if I look at my choices, it's asking for obtuse and what kind of triangle is it classifying it by its sides. So if you look, all 3 of these sides are different lengths, so that means it's scalene. So our triangle is obtuse and scalene. Okay. Try the rest of the practice problems if you haven't already on the back of this note packet, and we will go over any questions you guys have in class.